In this video, we are going to figure out how to solve equations with variables on both sides of the equation. Let's jump right into it. The basic idea here is that what you want to do is you want to get the equation to a position where you can undo the order of operations. And what this means is we need to get it so that when we have variables on both sides of the equation, we end up, after our first step or second step, with variables on just one side of the equation. And so how do we do that here? Well, you have options. We could either move this x value to the left side or move the minus 3x to the right side. And I'll show you how to do one of those. I'm going to choose to move this term over to this side because to undo minus 3x, I'd have to add 3x. And adding 3x to a positive x will give me a positive 4x. I'll show all that out, but I like to keep my coefficient, the number in front of the variable, as positive as possible. So I'm going to undo minus 3x by adding 3x. And of course, what I do to one side of the equation, I must do to the other, right? That is the old foundation of all equations. Negative 3x plus 3x, that cancels out, leaving us with 14 equals, when I add 3x to x, we get 4x minus 6. Oh, what's very nice about this is that we now just have a simple two-step equation, and this is something that you've solved before. So to undo the order of operations, we are going to add 6 to both sides. Very, very nice. The 6's cancel, and we're left with 14 and 6 is 20, which is equal to 4x. And now we're left with a one-step equation. To undo 4 times x, we divide by 4 on both sides of the equation. And that leaves us with 4's canceling, and you get x is equivalent to 5. Now again, the most important part I need to point out here is, like in many math problems, you really only have a little bit of new information that you're learning here. It's joining one variable with another so that you end up with an old friend, a two-step equation. And then this problem is no longer a new problem, it's something that you've solved many times before. Very, very cool. Now at the end of the video, I'm going to come back to this problem and show you how we could have moved the x over to the left side of the equation and still gotten the same answer. I'll do that at the end as some bonus coverage. Okay, on to this problem to my left, which would be your right. Okay, so we're looking at this problem. Now we've got decimals. Oh no, not a problem. We deal with it in the same way that we dealt with that last equation. So again, we're going to join up the variables together. I notice that we have a larger variable coefficient on the left side and a smaller coefficient on the right. I am going to undo plus 2.9a and move it over by subtracting 2.9a from both sides. Again, the goal is to join the variables together so that I get into a position where I can have a two-step equation, or a simpler equation to undo the order of ops. The 2.9a's cancel out. We do a little bit of math here. We're going to get 2.1 plus 3.3 minus 2.9 is 0.4a. A little bit of decimal action is equal to 6.3. Ah, we get a two-step equation. To undo plus 2.1, we subtract 2.1 from both sides. Nice. And so the 2.1's cancel out, leaving us with 0.4a is equal to 6.3 minus 2.1 is 4.2. Now we want to undo 0.4 times a, so we divide by 0.4 on both sides. And we're left with the fact that the a is now isolated, which is what we wanted, and 4.2 divided by 0.4, you can either do that with a calculator, do that with some mental math, however you want to do it, you end up with 10.5. And that is your answer. Very, very cool. So, solving equations with variables on both sides adds a little bit of extra thinking where you need to join the variables together, and then you end up with a nice old friend, a two-step or sometimes even one-step equation. So, as I promised here, you can end the video if you like, or a little bit of bonus coverage. I'm going to show you how we could have solved this problem right there by moving the x over to the one side. So, I'll put that right in the middle. So, we would have had minus 3x plus 14 equals x minus 6. So, we could have moved the x over to the left side. That's totally cool. To undo positive x, I would subtract x from both sides. Notice that'll give us negative 3x minus x. The x's will cancel. And we end up with minus 4x plus 14 equals negative 6. So we end up with opposite signs of what we had there. I'm going to undo plus 14 by subtracting 14 from both sides. So I end up with the 14's canceling. I get negative 4x is equal to negative 20. And now I divide both sides by negative 4 to undo minus 4 times x. And that leaves me with x is equal to negative 20 divided by negative 4 is positive 5, which is the same answer we got. The only difference is we had a lot more, well, many more negative numbers to work with. As always, to check your solutions, you can take your answer and plug it into the original equation and you will get a true statement. So I'll do that now. So I can take x equals 5 and put it into negative 3 times x, or negative 3 times 5. As always, that x is an empty holding tank that I'm plugging in 5 for, plus 14. And the question mark means, is it equal to x, which is 5, minus 6? Well, negative 3 times 5 is negative 15, plus 14 is negative 1. And 5 minus 6 is negative 1, which is a true statement. So we know that our answer of x equals 5 works. That's all I've got for you, peeps. I hope you enjoyed it. Solve those equations with variables on both sides and feel good about it.